In this video, we are going to go over the functional group of alcohols. So alcohols are a class of compounds that contain a hydroxyl group or an OH group. Oxygen is bonded to a tetrahedral carbon or singly bonded to a carbon, and the tetrahedral carbon bonded to other carbons. So general definition of alcohol is ROH, where R refers to the rest of the molecule. So you'll see here that we have a carbon bonded to an OH group. Same with over here. And then this is a condensed structure. The R this is the OH, and this is the rest of the molecule. So this is R. The oxygen of the hydroxyl group has a tetrahedral electron geometry and bent molecular geometry. It has two non-bonding pairs of electrons and two bonds. So that makes it a bent geometry, molecular geometry. Some examples of alcohols is methanol. It's a one carbon alcohol. Two carbon alcohols is ethanol. And then two propanol is shown, and another name for it is isopropyl alcohol, or you probably heard of it as rubbing alcohol. So there are different types of alcohol, and the chemical reactivity of an alcohol depends on whether the carbon that the bond to the OH group is bonded to one, two, or three other carbon atoms. So a primary alcohol, the COH group is bonded to one carbon, R group, and two hydrogen atoms. A secondary alcohol, the carbon of the COH group is bonded to two carbons and one hydrogen atom. And then a tertiary alcohol, the carbon that's bonded to the hydroxyl group is bonded to three other carbons and no hydrogen atoms. So if we look at these, we see that a primary alcohol, the carbon bonded, so we look at this carbon, that it's bonded to the alcohol. It's bonded to two hydrogens and one R group. So primary, it's also shown as a 1 and then a degree. It's bonded to one R group. Secondary is bonded to two R groups or carbons. Tertiary is bonded to three. So to indicate whether each of the following alcohols is primary, secondary, or tertiary, so pause the video, and then when you're ready, come back. So when we look at this, we look at the carbon attached to the OH group. This carbon attached to the OH group is bonded to one carbon, two carbons, and a hydrogen. So this is secondary. We look at the carbon over here attached to the oxygen. It's bonded to one other carbon. So this is primary. We look at this carbon that's bonded to the oxygen, the OH group. It's bonded to one, two carbons, so it's secondary. We look at the carbon right here that's bonded to the OH. It's bonded to one, two, three other carbons, and therefore it is tertiary. There are different types of alcohols. There are diols. Diols are structures with two hydroxyl groups on them. Triols are structures with three hydroxyl groups. Polyols are structures with more than three hydroxyl groups. So we can see here that ethylene glycol, propylene glycol, and glycerol are all have more than one hydroxyl group. And we see that ethylene glycol and propylene glycol are part of antifreeze. Glycerol is a product of glucose and fat metabolism. And then we also have glucose, which is a polyol, which means it has lots of hydroxyl groups. So lansoprazole is used as a treatment for glaucoma. Circle and identify the alcohol functional groups, label the hydroxyl groups as primary, secondary, or tertiary, and is latanoprost a diol, triol, or polyol? Okay, so we're going to circle and identify the alcohol function groups. Remember, alcohol is OH, ROH. So we have OH here, OH here, OH here. This is bonded to 2 carbons, so this is secondary. This is bonded to 2 carbons, this is secondary. And this one's bonded to 2 carbons as well, so that's secondary. This has 1, 2, 3 alcohols, so it is a triol. So physical properties of alcohol, solubility. The OH group is very polar and is able to form hydrogen bonds. However, alcohols also have the nonpolar carbon-carbon single bonds and carbon-hydrogen bonds. So solubility, since likes dissolve likes, the water solubility of an alcohol depends on the number of hydroxyl groups it has relative to the number of carbon atoms or carbon-carbon single bonds it has. So when you have 1 carbon and 1 OH group soluble in water, 2 carbons, 1 hydroxyl, 3 carbons, 1 hydroxyl, those are all soluble in water. But as you increase the number of carbon atoms, you decrease your solubility. So increase carbon atoms, you decrease your solubility. But if you increase your number of hydroxyl groups, you increase your solubility. Because now you have more chances to hydrogen bond. So glucose has 6 carbon atoms and 6 hydroxyl groups. It's water soluble and it dissolves in blood for transport. We need glucose to live. Cholesterol has 27 carbon atoms and only 1 hydroxyl group, and it's very insoluble. And it's transported within lipoprotein complexes in the blood. So the boiling point of alcohols, due to the hydrogen bonding in alcohols, this accounts for their higher boiling point when compared to molecules of similar sizes. So you can see here, we have our alcohol group right here, and the oxygen of the alcohol can hydrogen bond with the hydrogen of another alcohol group due to their different dipoles, and then we can have those intermolecular forces. Since hydrogen bonds are stronger intermolecular forces and therefore require more energy to break, so their boiling point, that's why alcohols have higher boiling points. Methanol, ethanol, and 2-propanol are liquids at room temperature, whereas alkanes of similar sizes are gases. So this is just telling you how alcohols at the same number of carbons of alcohols are liquids, whereas alkanes, they are gases. So alcohols are molecules that have a hydroxyl group or an OH bonded to a tetrahedral carbon. The oxygen center has a bent molecular geometry. The chemical reactivity of an alcohol depends on whether the carbon with the bond to the hydroxyl group is bonded to 1, 2, or 3 other carbon atoms. And compounds with more than 1 hydroxyl group are called diols. Triols have 3 hydroxyl groups, and polyols have more than 3 hydroxyl groups. The OH group is very polar and able to form hydrogen bonds. Water solubility of an alcohol depends on the number of OH groups relative to the number of carbon atoms in a molecule. Then hydrogen bonding in alcohols accounts for their higher boiling points when compared to molecules of similar size.